Hello, everyone, and welcome to today's webinar. We're just waiting for everyone to join. In the meantime, enjoy this short video. Good morning or afternoon, everyone, from wherever you join us today, and welcome to today's webinar, Transformer Protection Testing with our Regional Application Specialist, Mohamed Ibrahim. My name is Marwa Alawi, and I will be the moderator and support for today's webinar. I would like to draw your attention that the microphone, as you can see on the control panel, has been put on mute by the moderator to ensure a silent environment for the benefit of all our participants. If you're facing any trouble hearing us, please ensure that you select your preferred headset or speaker from the audio section in the panel as illustrated on the slide. Later in the Q&A session, you can raise your hand and I will turn on your microphone to allow you to ask your question. Please note that this webinar will be recorded. However, we will stop the recording at the Q&A session. To ask any question throughout the session, please choose the question dedicated area as illustrated on the slide. We will try to answer as many questions during the webinar as possible. However, in the case a question is not answered during the webinar, please note that it will be answered in a follow-up email. You can also get in touch with us or ask your questions through the chat section. We will have some poll questions during the webinar that look like this. All you have to do is click on your preferred answer. Some polls may appear in a separate window. If you face any difficulties in showing or answering polls during the webinar, we recommend that you change the browser you are using. Please make sure to download the presentation and the product brochures from the handout section. Please take note that the contents of this presentation are Omicron's sole and exclusive intellectual property. If you wish to record, copy, or otherwise distribute said contents, please request prior written consent from Omicron. You should also not post any webinar videos, accompanying file content, or links to them on any public social media platform such as LinkedIn, YouTube, Facebook, Twitter, or any other platform. The recording of this webinar will be sent to you in a follow-up email, which will also include a feedback form. We would appreciate your response to help us better serve your needs in the future. We have a couple of exciting announcements. Omicron recently launched its podcast series, Energy Talks. A podcast is a series of digital audio talks where experts, users, and industry peers share their views on various topics related to power system testing. There are a couple of episodes already out covering partial discharge and rotating machine. You can tune in to the podcast online, and it's also available on Spotify, Google Podcasts, and Deezer. More episodes will be available soon. We will share the link to the podcast in the follow-up email, which you will receive after this webinar. Finally, we're also excited to announce the launch of the new LinkedIn Omicron MIA page. The page serves as a platform to share the latest MIA power system updates, and content that you can expect on it is technical papers, case studies, and events and webinars updates in languages of Arabic, English, French, and Turkish. We will share the link to our new LinkedIn page in the follow-up email as well. We kindly invite you to follow us to stay connected and updated. Before we get started with today's webinar, I would love to know what challenges you face during in your work environment. I will now launch a poll question about that, and I invite you to answer. I will keep the poll open for another 10 seconds. If you can please cast in your answers. Thank you so much for answering. We see that 60% of our participants today, the challenge they face is time, and we have also 18% with safety and 14% who answered effort. Thank you for answering the poll question again. Enjoy today's webinar. I will now hand over the virtual floor to my colleague Ali Dawood, Area Sales Manager.
Thank you, Marwa, for the introduction and welcoming the attendees for today's webinar under the title Transformer Protection Testing. I hope my slides is visible to all of you. We have got more than 500 registration today, so you are one of the luckiest people who have accessed the webinar today. So we hope you will have a great knowledge sharing with us today. My name is Ali Dawood. I'm Area Sales Manager, and I will be the moderator for today's session. Here is my contact details as shown up there. So I will be happy to be with you during today's session to answer your question and support the main speaker, who is Mohammed Ibrahim. I believe most of you have met him or talked to him during this time, because he has conducted a lot of practical training courses and also troubleshooting technical problem for our customer. Furthermore, Mohammed developed application note and application and technical paper for Versus application. He is a very experienced engineer in industry, and he has already been working in Versus companies in Egypt, in Saudi, and now in Bahrain with us in Omicron. He has more than 18 years experience, around 12 years in GCC, and again since 2015 with us as in Omicron as regional application specialist. Mohammed finished his BSc degree in electrical engineering in 2002 and his high postgraduate studies Diploma in Electrical Power Engineering 2007. About us in Omicron, we are a manufacturer of testing and measurement equipment. We develop innovative top quality testing and monitoring solution for electrical power system. The majority of development and production work takes place at our premises in Styria, as well as in Berlin for partial discharge product. As of today, we have more than 900 employees from 45 different countries and 25 regional offices worldwide. In addition, we have a strong network for sales partners in various countries. So please visit our website to know who is your nearest local support you can approach. As mentioned by my colleague Marwa, you didn't need to record anything. We will make the recording and share it with you. Please visit our website www.omicronenergy.com and visit our LinkedIn to get yourself updated with our news and new product. Thanks for your patience with me, and now I'm handing over the mic to my colleague Mohammed Ibrahim to start the presentation. Mohammed, floor is yours.
Good morning, good afternoon, good evening for all of you based on your location and your local time. Welcome everybody to our today webinar, which we will discuss together about differential protection testing. Mainly, we will focus on transformer differential protection. And to start this webinar, let's start with agenda for today's webinar. The first one, or the first point, we will focus on the theory of the differential protection. Then we will follow with that with test differential protection with Omicron solution, and Omicron solution provide two type of testing: system-based testing and protection parameter setting based testing. If we talked about the parameter setting based testing or setting based testing, which is a conventional method, and it's likely to check and verify the relay setting. And the second approach, which is called system-based testing, and in Omicron we call it relay sim test software. A lot of benefit, a lot of options that we can use in system-based testing side by side with the conventional to increase the quality of the testing, and we will see and learn how to use both of them together to maximize the quality of our testing. Let's go to the main topic, which is the differential protection principles. As we see right now, this is as image about a power transformer. We have two sides, primary and secondary. And as you see here, it is connected to two in feed. Sometimes it's one in feed and one load, whatever, but it has two sides. And for sure, definitely, it has two different turns ratio. Winding 1, winding 2. It is used for stepping up or stepping down as a power transformer, which is used in our power system. And to simplify that, I will represent it in a single line diagram. As you see here, we have the two windings. Sometimes we have a tertiary as well. At that time, we will have three winding, but as we see right now, we have a primary and secondary two winding as well. The benefit behind using the transformer differential protection is the differential protection is a unity protection. What does it mean by unity? Unity, it means that it is detecting an internal fault and it will be restrained or stable against the external fault. Let's give one example. If we have an external fault here, the differential must not issue any trip related to differential trip, because it is external fault and should be stable, because current in equal to current out. And if we have an internal fault, immediately, instantaneously, very fast trip will occur, and it will trip both side circuit breakers. And this is a very important and very selective uh, uh, trip command because it can recognize the internal fault and also the external fault to avoid a misoperation. And it is very fast tripping. That's why we would like always to use differential protection to be applied in our power transformer. For sure, we cannot apply it in small or low voltage power transformer. Only we have a limit of 5 megavolt ampere and above. If it is less, it's based on the priority of this power transformer to apply that differential protection because it's costly and we have to make sure that this cost is not expensive compared to the price of the asset itself. The same thing also if we have an internal fault between the two CTs, not only inside the power transformer tank or inside the winding itself, it should be also issue a trip. As you see here, it's a kind of a fault between the CT and the winding. It can be maybe between the pushing and the winding, and should be also considered as an internal trip because the differential we recognize the fault between the two CTs, between the two sides as you see it right now. Why a power transformer is different, power transformer differential is different than line differential, for example. This will show us some of the reasons that it make it different than line differential. The first point is we have a current magnitude on both sides are different. As you know, we have a different thickness ratio. Primary is completely different than secondary for sure because we said power transformer stepping up or stepping down. That's why we have a different current value. And also we have a vector group which will also affect on the angle, the phase angle of the phases different between primary and secondary as well. And also we have a different CT ratio from both sides, and this also makes it is a little bit complicated compared to the line differential, which has the same voltage, sometimes mostly same CT ratio both sides, and it is easy, no vector group at all. But some cases we have a line differential including transformer in zone, but here I was talking about a pure line differential without any any transformer in zone. We have something else. We have to take care about zero sequence elimination. We have to apply this technique in case you have the star point grounded or you apply this vector group at any side. You have to apply the zero sequence elimination to avoid misoperation. Why misoperation? We will see it later, but only to give a hint that this can cause a misoperation in case of external line to ground fault because it will circulate current in the protected zone and it can be detected by the differential if we didn't apply zero sequence elimination. I hope it is clear for all of you. Let's talk about one of the important points why we need to apply different slopes in in the power transformer differential protection slopes. Why it is different, sometimes 3 slopes, sometimes 2 slopes based on the relay manufacturer. Why we need it, why it's not like a definite time over current, for example, only a single point setting of the current, if it is exceeded, should be tripped, and that's it. It's not possible because of many reasons. Let's discuss about some of it. The first one is the magnetization of the core. As we know that once you energize a power transformer, even without connecting the output side, which is sometimes the secondary, side, for example, some current or some power will be injected inside the iron core to do the magnetization of the iron core of the power transformer, and this current will not get out of the transformer. At that moment, this means that the main concept of the differential will not be applied because current in, not out, which is the magnetization of this iron core. This should be considered and to be avoided in the setting calculation. It is very less based on the design of the power transformer. The second point is the leakage due to the tab changer. We know that we have a tab changer. It's based on the manufacturer as well, also on the application of the buttons form. Sometimes we have it in the high side, sometimes we have it in the low side based on the application of the buttons form, because I saw both of the application available at site as well. And coming back, we have a current leakage due to the tab changer. We have to also avoid that in setting calculation. The third point which we need to talk about here, proportionally CT saturation. We know that with the heavy external fault or with any high current fault, CT can be partially or fully saturated, which will affect on our protection, especially in the differential, because both will not be equally. Here we need to define that we have two elements should be calculated, restraint, which sometimes we call it bias, and the other one is called the differential. Let's see the slope and how we can see the operating characteristic. We have a relation here between the differential and the I bias. As we see here, the differential is I primary minus I secondary, and I bias magnitude of I primary plus I secondary. Actually, this is not true in all relay manufacturer because we have a different bias equation. We will talk about that one later, but to simplify, we can use this concept as well to draw the characteristic or the operating characteristic. Let's start with the magnetization current, and as we talked about this in the last slide, this is a fixed current which it will flow inside the iron core, and it will not get out from the power transformer. Then it should be considered to be avoided in setting calculation. The second one is a tab changer leakage, and this will be related to the tab position and also the current, or you can say the load condition. Then it will be increased with higher loads. The third one, which is very, very important to be considered, also the CT saturation. As we see here with the heavy external fault, it can cause a kind of partial saturation, which it can push the differential protection relay to misoperate. But for sure, we know with a new digital and numerical protection relays, it has a internally compensation for such kind of saturation. And we need to make the summation of all of these factors. And for sure, our setting should be avoid at the minimum setting I differential greater to avoid more than those. We have a I differential double greater is the maximum limit, the high stage, sometimes we called it. And after that, we have to draw our characteristic and calculate our slope to avoid such problem, especially with the heavy external fault. This is how we can calculate the operating characteristic for our power transformer. And as you see here, the area below the curve or the slope will be a blocking area. We call it sometimes restrained or biased area. No trip will occur. And in above should be the trip area, and the trip area in any case should trip if we have the differential current allocate in this area with this yellow color. If you remember last slide, we talked about different bias equation. As we see here, we have different examples from different manufacturer, and all of them are correct. Each one of them try to put his innovative ideas about how to do better bias calculation for their protection application. And this make some challenge for the commissioning and maintenance engineers to take care about that. We don't have a fixed equation for all of the relay manufacturers. That's why we have to consider that once we will start to test differential protection for the transformer. You have to take care about the bias equation, which is also be considered inside our test module during testing. Let's go directly to transformer differential relay, how it is connected to the system, and what is the what is the main test points which we need to check, which is recommended from Omicron to be applied to do the testing or the maintenance for such kind of application. Point number one, which is a wiring check. This wiring check is a very, very important before starting any test file. You have to verify that your wiring is connected correctly by injecting different current value, different voltage value in case if your application needs voltage as well. These different values, you have to read it out from the relay, which is under test, to make sure that your wiring is correctly. Please consider this as a very important, not to lose your effort and your time in case you make any miswiring or wrong wiring, because it will delay your progress in the testing. The second point is the first trip, which we consider as a general fault. You can create this general fault to verify that the relay is still acting and giving a feedback. Because sometimes during the maintenance, routine maintenance tests, which is sometimes in some utilities testing every 4 years, sometimes the relay is defective or it has a big problem, and instead of doing the full test from the beginning, you can get the indication that you have an issue. Don't waste your time, and from the beginning you can consider that this relay is defective and not to continue for the following points. Point number three is a backup test, which is also can be considered to check the sensitivity of that relay, the minimum current. If you remember, I differential greater can be used as a parameter setting to check backup and drop off, and it can be tested by using ramping test module. Point number four is the stability test, which is very, very important, and we have here a test module called the configuration test module, which is checking the stability of the secondary circuit of the protection relay. Point number five is a characteristic test, the operating characteristic. We will talk about that one in details. Number six is a trip time, to check the trip time of the relay. Number seven is a harmonics block test, and we will talk about that one. And only just to highlight that we can check the second harmonics avoid the inrush current with the energization of the power transformer, and also the fifth harmonics avoid the over excitation, and during the over excitation it should block the differential and keep the other protection function to detect the over excitation V over F, to trip the power transformer, not the differential itself, because this is not a differential fault. And the second harmonics to block the differential protection during the inrush situation or inrush current based on the second harmonics value. We have a test module called harmonic restraint. It can be used to check that. And for sure, the last point, to make a verification that your protection system is completed by injecting a fault condition and checking that it is tripping the circuit breaker to make sure that your protection scheme is completely correct. Our example for today will be about GE relay B6 MICOM B643 as a transformer differential protection relay. 3 to represent 3 winding. This is the protection setting, 50 Hertz, 160 MVA, megavolt ampere is a rated power for this power transformer for primary side, and the voltage primary side 231 kilovolts, and secondary side 115.5 kilovolts, and the rated voltage or rated power of the secondary 118 megavolt ampere, and the tertiary 10.5 kilo volt and power 42 megavolt ampere. The vector group y0, yn0, d5, and CT ratio in primary 400, secondary is 2400, and tertiary 600. Due to side 1 will be represent the primary, side 2 will be tertiary, side 3 will be the secondary as per the relay manual. And we have the main setting. 0.25 is I differential greater, 6 ampere is the I differential double greater. I change it to 10 ampere in our example. And slope 1 0.3, slope 2 0.7, and the bias current is for I reference. And we have the harmonics, second harmonics is 20% Y differential. This is general about our setting for today for the practical session. And let's start with the steps which we have to follow to use Omicron solution for testing transformer differential relays. For sure, we have three parts. We have the protection relay, we have the CMC test equipment, we have also the software, which we call the test module based on the test universe. And as you see here, we have to establish the communication between the CMC and the PC. We have to connect the current and voltage based on the application. In our application today, we will use only current because it's a low impedance differential transformer or transformer differential. And we have to connect also the feedback. Trip contact is more than enough in this application. And for sure, checking that everything is communicated correctly. Let's start with the Ohm's law. In Omicron, we use the Ohm, OHM, to do any kind of testing by using test universe. O will represent is a test object, which is the device under test. H is representing hardware configuration, which is related to the configuration of the test equipment, like how many current channels you need to activate, how many binary input, binary output you would like to activate based on your application, and for sure ended with the test modules, which how many test modules you would like to apply, or which test module you would like to apply. Let's give you an example. We have here a differential protection. This differential protection, for sure, we have to apply differential protection test modules, which is not applicable to use a distance protection, for example, in this application, or overcurrent in this application if we are testing only differential function. Because as we know, numerical relays right now has a lot of protection function in it. It has overcurrent, sometimes distance as well. In some countries, I saw that they are applying distance protection in a power transformer to protect each winding and representing this winding as impedance. And that's why they are using distance protection to protect the winding, and at the same time also they use this function as a backup. But the main function is differential protection for sure. Let's again confirm this information that we have to start with the test object, which is a relay setting. Second one is hardware configuration, the configuration of the test equipment, and the last one to select the test modules which would like to use to test our protection function. How we need to connect. As we see right now, for transformer differential, for sure, if we have a two winding, we have to connect primary and secondary as well, as you see it right now. We can use two different commands, two binary input, one for high side, one for low side. Most of the application we use one general trip instead of two. We will use only one. We have here a positive and negative for the binary input. We will talk about that one later. What does it mean and why we need it? After that, let's start with the test object. The first step, test object, as we see here, there is in any OCC, you will find that the test object symbol is available. Double click and you can find here the RAIO block related to differential. We need to start to select which asset we need to test. We have a transformer, we have a generator, pass for line differential, and pass power protection. This generator can be considered for generator and for the motor as well. For sure, if you select transformer, you will find that vector group is available. How many number of winding? 2, or you have a tertiary. At that moment, you have to select 3, and after that, you have to give the information about the primary side and the secondary side related to the voltage and power, and also the vector group, and if it is star pointed, grounded, yes or no. And after that, we have to also give the information about the CT ratio, primary, secondary for the primary side, secondary side. Then protection device, which is representing the minimum setting, and the bias equation based on the relay manufacturer as well. Then we have a characteristic definition, which is representing the slope 1, 2, or sometimes in some relays we have 3 slopes. And also after that, we have to define the limit of the harmonics for the second and fifth harmonics as well. Let's talk about the differential and how we can differential operating characteristic and how we can draw it. As per our example, I got this from the relay manual. B643 or B642 is the same family, and we have some setting inside the relay. We have IS1, which is representing I differential greater. We have HS1, which is I differential double greater. We have also IS2, IS-HS2, which is a which is double greater with a high set, but I will consider only ISHS as a high set, I double greater. We have here, as you see, 3 slopes, 3 portion. Portion number 1, here we have I differential greater, which is IS1. After that, we have K1, which is a slope number 1. After that, we have also K2, which is a slope number 2. I hope that now it's clear. Here we have 3 sections, section 1, section 2, section 3. This is a setting, this is a setting, this is a setting, this is a setting, and also IS2 is setting. Then we have to define this point, that point. Luckily, in this relay, we will start from point origin, which is 0, 0, which is make our calculations more easier. Let's see how we can draw, because this equation we need to draw this characteristic in that test object for sure. Maybe some of you will say, okay, why we need it? We can use PTL. Sure, definitely. PTL is available there, but always we are saying that PTL is for saving your time as an expert. That's why we need to learn how to draw it to become an expert. And after that, if you face any issue during applying the PTL, you can solve it easily. Here in the green color, this is the setting from the relay. IS1 0.25, which is I differential greater. IS-HS1, I put it as 10 as I differential double greater. I have K1, which is slope 1 0.3, and I have K2, which is a slope 2 0.7, and I have IS2 is 4. Then we need to define those points to find point number 1, point number 2, point number 3. Point number 1, it is easy because we can use 0, 0. It's passing with the origin. And how to calculate? Very easy. We can say that I differential equal to 0.3 as a setting, multiplied by I bias plus A, but because it's passing with the origin, then the A equal to 0. Then I differential for the third slope or the third section is equal to 0.7 multiplied by I bias plus B. Let's start with point number 1. From the equation, we can get point number 1 is 0 and 0, point number 2, 4, and second point of I differential 1.2. And after that, we can also find the point number 3 at the 2.16.57 as a I bias, and 10 is I differential as well. Because I differential here, this is for representing the setting. 4 here is this one, and 0 and 0. Then you have triangle here, delta differential divided by delta restraint equal to tan delta equal to slope. From this equation also you can use to find the missing parameter, and after that you have to define those points which is used to draw your operating characteristic. This is how it's look like. And to test this operating characteristic, for sure we have two techniques. Technique number one is shots. These shots, it means we have to allocate points, different points, under the slope and above the slope. We consider all of this area as a trip. This is no trip, and the test module will check if we got a trip here, it will be failed. If we got on trip here, it will be failed. Then it will check the tripping area and the biased area as well. Then the second technique we called it surge. If you tested the distance protection before, we have also shot, we have also surge. The surge, it will look like that. As you see here, the point, if you select the point line, it will go up and down until getting the maximum accurate point, which is should be allocated on the line with within the tolerance. And for sure, we need to apply this 2 point at least for each line slope to verify that slope is correctly as we are setting or not. This is how it is working, in search technique. And for sure, it is if it is within the tolerance, it should be passed. Let's talk about the after we draw the characteristic, we get to know about the difference between shot and surge. Let's talk about the harmonics. The same as we mentioned before, we have the second harmonics, we have the fifth harmonics. Second harmonics to avoid a misoperation during the inrush current. And how we can detect this by the setting of the second harmonics. For example, in my setting here, we have 20% of the second harmonics. The second harmonics, if it is more than 20%, at that moment differential will be blocked until passing this time of the inrush, and after that the second harmonics will be less, and it will be ready to protect the transmission line, the power transformer during the energization or working time. If we have the fifths to avoid the overexcitation, we know that for overexcitation we have V over F protection. This will be considered as a protection element to protect the power transformer against overexcitation, not the differential itself. The differential during that time should be blocked, and fifth harmonics will be the reference. If the fifth harmonics is more than the limit of the setting, the differential will be blocked. This means that this transformer is under overexcitation condition, and V over F has to take the role of the protection, not the differential as well. Here again, coming to the second point, we finished already the test object. Now we come to the hardware configuration. For sure, for the hardware configuration, you have to define how many current, how many binary input you need, how many binary output you need, even if you need DC to configure the DC. All of that we will see it later here in this slide. As you see here, this is a transformer differential protection relay with a tertiary side connected to the system. Three phase CTs in the primary side, 3 in tertiary, 3 in secondary as well. And we have a differential with 0, and we have a bias. This is under the operation condition. And if I need to test, for sure, transformer should be out of service, and at that moment you can use a test block in the secondary to do short and isolate for this for the current secondary circuit. And for sure you need to connect your CMC to the power transformer. Maybe some of you will say, okay, we have only 6 current in the stream, CMC 356 or 256 plus. How we can test with the tertiary? No problem, no issue. We can test now primary to secondary, and after that we can change from primary to tertiary, and after that from tertiary to secondary as well. At that moment In the BTL, we already covered that, and also we can do that in the OCC. In the relay sim test, we'll do the test one time with the tertiary as well, and we will see that together during the practical part. This is how it is connected. As I mentioned that before, we have a primary and secondary side. This is how it is connected. CMC, we have here three-phase current for primary, three-phase current for secondary, and we can use two-trip condition to be connected. But here in my example, I will use only one general trip for one single binary input. If you remember, I told you we have a binary input. It can be used positive and negative sign. As I mentioned before, I was meaning the difference between wet contact and dry contact. Dry contact, we know already that it is a free contact from the relay connected to the CMC, and it will detect the continuity. If it is zero resistance, it means that the contact is closed. If it is open, it means higher resistance. But with a wet contact, which is preferred, why? Because mostly the used contact with the lookout or the tripping coil of the circuit breaker will be wet condition, and we always use to try the contact which is used in the protection scheme for the tripping. And as we see here, the condition number one, if this closed, the positive will transfer to come here. This is a positive, and here we have a common negative. Across the binary input, we will have the DC voltage across. Then the CMC automatically will detect that the trip contact is closed due to sensing the voltage. But in the dry contact, it will sense only the resistance of this contact of the loop, the closing loop. No DC here as well. Another step which is very important is connecting your CMC to your PC. As we see here with Net2, this is the latest technology which we have. Net2, here we have Wi-Fi stick. If you would like to control it wireless, you can use it with a USB cable, same exactly cable of the printer cable. You can use also two RJ. You can use any of them, any one of them, one or two. This Ethernet port or RJ45. You can connect it to your PC, and be careful about the IP address in case you have a static IP, or you can make it automatic IP address in both in your PC and your CMC as well. This is how it's look like, the hardware configuration. For sure, you have to configure by pressing the configure, and you can select how many current and how many voltage you would like to use due to your application. You can also assign the number, the analog and the binary input, dry and wet, and also the binary output is needed in some application. DC analog only required in testing transducers, and we have a time source in case you would like to use this in the end-to-end testing. But in bar transformer or the conventional testing of the bar transformer differential right now, I don't need it, but I will use it in the relay sim test, and I will show you why we need it in relay sim test, but not need it here. Okay, let's start with the third point from the Ohm law, which is the test modules. If you remember, we have O, H, M. Now the time for M, and for the test modules here, as we mentioned before, the recommended 8 steps to test any power transformer differential relay. We will start with the stability, which is represented by differential configuration test module, which check the stability. What does it mean by stability? It will simulate external fault or a normal loading, and the relay must be restrained. No trip occurs. If trip occurs, at that moment it will give you fail. And the second one is a characteristic test to check the operating characteristic. We discussed that by two techniques: shots or search. Sorry, I will mute. I muted my mobile. Okay, let's go back here for the trip time test. And for the trip time test here, as we see, to check the trip time for sure, to injecting the differential points, which it should lead to the differential trip, and the test module will get the trip and give you trip time. And the point number 7 here, representing the harmonics block test for against the second harmonics and the fifth harmonics, based on the relay setting as well. Now we already completed the Ohm law, OHM, and how it's look like. We need to adjust the toast module by using the general setting. Trigger condition should be verified and all of that stuff as well. Tripping time, how it's look like. Exactly similar to the same operating characteristic, but at that moment we don't care about the operating characteristic for sure. We only will allocate a testing point above the slope, which is representing tripping points. And actually, it will, instead of bias and differential slope, we will have the relation between the I differential and the time. And for sure, we have to put different point and getting the trip time, and less than I differential, for sure it will be no trip as well. Now let's go for the practical part. We will do and apply this technique practically by using CMC with the protection relays, which I mentioned, GE MICOM B643. Now I will close the presentation for now, and I will open the practical part, which is related to the OCC file. As we see here, this is the OCC file. Started with the test object, then the hardware configuration, then we need to add the test module. We will start with the test object. I feed the information in advance to save the time of the webinar. Here, this is the general information before beta reporting. 3-phase for sure, 50 hertz. The primary side, the voltage, line to line, line to neutral, and the same for the secondary of the VT. If it is connected or applicable, it will be should be fed here. The CT ratio, the maximum limit of current and voltage, and this is the most important of the variable block of the differential. Here, transformer is our test object or our protected object. Then we have the vector group. We have tertiary as per the relay setting. We need to feed the information for the primary side, starting with the name, voltage, power, and also don't forget if we have a star point grounded, should be yes. For secondary, voltage, power, same, but here we're going to have grounded, and for tertiary, the vector group, power, and also the voltage. The CT ratio for each side. Here we have to select as per the relay manual which equation the relay manufacturer apply, and don't forget also this is the minimum setting, I differential double greater, trip time as well, going directly to the operating characteristic. This is the same point which we already calculated, and don't forget the harmonics, second harmonics and fifth harmonics based on the relay setting. Now we finish the test object. Now we need to start with the hardware configuration. Let's now, I will open now the webcam or the camera to show you how we connected this protection blade with the CMC, and I will make it power up. As you see here, now I will turn it on CMC. I already connected 6 current output, 3 combined generator cable, and 3 normal leads connected to the protective relay, which is already under test, and this all through the test switches. Now I will open the hardware configuration and to check that CMC is connected to my system. It's not connected yet. Let's start and let's see. Okay, now it should be connected. Okay. I will disable the camera to make it full screen for you. Okay, now it is connected online. We don't need voltage. 6 current is okay for us. Make sure that the analog are checked. And here for the binary input, this is terminal block in case you need to save it for saving time in future, to make it very easy to remember which terminal point you need to connect. Here, in case you need to use wet contact, this is nominal voltage, but I have dry contact. Binary output in case it's applicable, if not, no problem. Here for the transducer, we don't have transducer here. And time source, which is not applicable in this test. Now I will start with the test modules. First of all, differential configuration, which I can do two things: wiring check at the same time the stability. Here I will make 100% loading of the transformer, maybe 3-phase if you would like. You can also use different fault loops. And also here, this is primary side. You can change this from here to make it the other side, as you see. And also you can play with the maximum time of the injection to get the chance to check the wiring by reading the relay measurement. And the most important thing, that relay will not issue any trip, because this is stable condition, and you have to press pass as indication that this test is already passed. Second test module will be differential operating characteristic. As we agreed before, we have shot and we have surge. Shot is very easy. I will put 1 point in the tripping area, 1 point in the restrain area, and also you can select which fault loop you would like to test as you prefer. You can make one for each fault type. Now I will do the same operating characteristic, but this time will be for surge test. I will select only one, or make two testing points, and I will add differential trip time for checking the trip time. In some relays, pre-fault condition is essential. You have to make it. This relay needs a pre-fault. I will make pre-fault for 2 seconds with 0.5 pre-fault current, and I will add some 2 testing points, and for sure this is a fault loop. And I will end that with differential harmonic restraint. Let's make one example with the fifth harmonics. From here you can select the fifths instead of second. You need to test both of them, second and fifth. I will add a short point of about 1 ampere. This should be trip. And make it add. This should be no trip. And let's start the test automatically. Only just click on start, continue all. Let's see the shot. Okay, the first point pass. Second point pass, no trip, of course. Okay, this is great. Now, I select the same shot points. Both are no trip. I forget to make search. After I finish, I will add one for search. Trip time, okay. Let's wait for the fifth harmonics. Listen. Okay, excellent. One is trip, one is not trip, which is exceeding the limit of the fifth harmonics. I will remove these, remove all points. Instead of that, I will make 2 search line for 2 slopes. And let's start. As you will see, points are going up and down until getting the best interact with the operating characteristic. If the point is between the boundary of the tolerance, it will be passed. If outside the boundary, it will be failed. First point is passed. Okay, done. Now we have a testing file which is ready. There is some tips and tricks you can insert. For example, a group. For example, if I have a multi-function, this function may be to be used for transformer differential. Other folder maybe for the overcurrent, and you can rename it here. For example, differential. And a lot of feature we can talk about it later on in a different webinar. I hope this is clear for you as a practical part for how to test transformer differential relay by using the parameter-based or parameter setting-based testing, which is test universe with test modules. And now it's a time for the new innovative solution, which is provided by Omicron relay sim test, why we need it, what is the new approach is, and let's start with the presentation again. I will close this. For sure you can save it and use it many times later on by using it, saving it in a safe place, but I don't need it now. And I will open again the presentation. It's coming back to the presentation. Don't forget that we have restricted asphalt REF, which we can also test. Few information about restricted asphalt, why it's needed. Actually, restricted asphalt is designed to protect the point which is close to star point grounded. And this area, if we have a line to ground fault, it will not be detected by the differential because it's very less current. And to overcome this issue, we can apply restricted asphalt. How to test it? Actually, we have different techniques. With Omicron, I can count three different techniques. Technique number one, we can use single phase differential. If you remember, we have a single phase differential in test module. You can use it, but be careful because it is supporting this bias equation, not applicable for any relay. It's applicable for MICOM B6 for X series. But if we have Siemens relay, for example, or Alstom B633 or different bias equation, you can use another technique which is supporting by differential operating characteristics, the straight phase, the same that which we already used for the normal differential for power transformer differential protection function. And you will find in the handout helpful files with application note. It will guide you how to show you how to use this approach. The third way, we can use state sequencer with some general test modules. It's also available in the handout through a link. And also we can use this new approach, relay sim test, to test restricted asphalt as well, as we will see together with this new approach and all the benefits behind that. Let's talk about the new approach, why we need it, why it's important, why most of the people like it. Let's jump to that. This is system-based testing. System-based testing, maybe the name is a little bit strange for some of you, some already familiar with that, and they are really users. And why it's important, let's start from the most important point. As per NERIC survey 2013, they found that the main causes of the misoperation maybe around 28% because incorrect setting, logic design errors, 20% of relay failure, relay itself, 17% about the communication failure, DC system 5%, and we have AC system out 9%, and left 9% as a personal errors, and 12% is still unknown. The good news that if we do a comparison between the conventional testing, which is the same method which we used by checking only the parameter setting of the protection relay, and compare that with the new innovative solution of relay sim test, which you call which it can be represent system-based testing, we will find that system-based testing is much more to add side by side to conventional testing. Let's give one easy example for you. As you see here in the right hand side and left hand side, in the right hand side we have a system-based testing, which is a relay sim test. Left hand side is conventional testing, which is a parameter setting testing, as usual, as we did already by using the PTL, by using the Ohm's law, test object, hardware configuration, test module. Same applications that most of the people are still using it, which is still available, and it's necessary to do it. But actually, we're still missing many points in the testing to raise the quality of this testing. What kind of important information we need to apply, we need to check. Let me give an example. As you remember in earlier slides, I showed that CT saturation or CT transient behavior is very, very important and very essential to be considered during testing transformer differential or differential in general. This is a very important point we have to consider. What else? We can also say that restrict fault can be done by system-based testing easily by controlling multiple CMCs with only one software. It means that, okay, I can test differential for tertiary 3-winding at the same time. Yes, this is what we will do right now after the theoretical part. And what else? Sometimes we have some phenomena like capacitive current for transmission line, for example, or mutual coupling for transmission line for parallel line. And those two phenomena, it's difficult to test it by the conventional, but with a new approach, it's very easy, it can be considered in it without any issue. Let's see in a basic way what is the difference between conventional and system-based testing. Let's start with conventional. It means that 1 plus 1 equal 2. Very easy equation, straightforward. What does it mean? If I have an overcurrent, for example, setting is 1 ampere, then I will inject 1 ampere and slightly I will increase a little bit. Then relay backup. Then 1 plus 1 is exactly 2. Very straightforward. The same injection. I got the feedback. Only relay is okay. I can say that, okay, relay passed. But actually, maybe this setting is not correctly calculated, or maybe it's correctly calculated, but some other factor not considered during the testing, like maybe 1 ampere. I give an example as well. It's not true, but for example, 1 ampere is it's full current. Maybe it leads to CT saturation. How I can consider this? How can I check that? How I can check this behavior? This is not easy to be considered in the conventional testing, because it's very similar to straightforward injection, 1 plus 1 equal 2. But coming to the reality, the real world, we can see here that the same equation for the same testing which is the second one, the second equation as you see it now. Maybe I can highlight it to make it more clear. This equation actually, which is a little bit complicated. It is the same value as the conventional, but we consider a lot of other reality like CT saturation, some distortion. It's not pure sinusoidal, very clear to the relay, but here we consider a lot of factors which the relay will see during the normal life, due to the real life. That's why the new approach should complete the solution, and side by side the conventional or the parameter-based testing with system-based testing will increase the quality of the testing for sure. We have to use both of them if we would like and need to overcome the misoperation causes, or most of it, honestly. Let's give you some examples. As we see here, this is a distance protection. It's not the same. It's not the main topic for us today to discuss. But okay, here I got that. Okay, green tech all passed, but maybe this characteristic itself is not adapted with resistance and reactance as per my transmission line, and some mutual effects can also do some bad effect on the performance of that relay. That's why relay sim tests can discover this easily by a very easy approach. We can see how we can adapt it and how we can use it. It's more easier than the conventional as well. Maybe another example here, it's very clear related to our topic today, due to the CT saturation. CT saturation can lead to the misoperation of the transformer differential. As you see here, the external fault turn into internal fault detection by mistake due to the CT saturation, and we need to avoid that. How to check that? In all days, if you remember, we use a technique of playback, which is extract the disturbance recorder and play it back again to the protection system, and check if this relay survive and prove that it is overcome this normal behavior of the CT or during the transient condition or not. And this technique actually is very limited because you have to wait until the problem happened, and then you will start from this point in relation. And also it's not applicable to try all the possibility of the different factors. But with a new behavior, with a new software, new approach, new technique, it's easy to allocate all of those points in one testing file with different test scenarios, as we will see together. What else? Nowadays, we have multifunction relays all allocated in one protection system and one protection relay, and to check and verify this overall protection scheme, it is not easy to be done by the conventional or the parameter setting testing. What is required to apply the new approach? Very few things which is required. Line impedance, short circuit current on the buses, we can say the impede, and CT and VT ratio. And don't forget, if you have the CT test result, it is necessary to be used to simulate more realistic waveform to be used during the test, and check the system capability against that phenomena of the transient behavior of the CT during the fault condition and during normal condition. Something else, yes, we can consider the saturation of the transformer itself. A lot of benefit, a lot of behavior can be done by using relation test again. One of it also, as I mentioned before, tertiary winding can be tested with a primary and secondary at the same time with a very easy steps. And this is second example, which I will show it to you. And also because as one software can control multiple CMCs with one PC, it enables you to test even the T connection, as you see here, with a complicated scheme like transformer in zone of the protected line, which is not easy to be tested by the conventional test method. Very easy approach. It's only we can summarize that we need a PC with a software for sure with a license to start to draw the topology of your protection system. Then automatically it will calculate and it will show the sine wave of the waveform of the expected or the calculated more realistic signal, which should be injected by the CMC into the relay and getting the feedback. That can be done very easy by using the relay test with the CMC directly. Something also else, maybe if we have a time at the end of this webinar, I can give a hint about time domain function, which is a traveling wave, which cannot be tested by the conventional method. Only the new approach can do that. Some challenges like series compensated line, which is difficult to be tested by the. It's not invisible, but a lot of efforts, a lot of time can be wasted in case you use this conventional method. CT saturation, the most important and effective method is relay test. Adaptive protection testing, also relay test can do it very easy. Something else I would like to show it to you here is relay test is a standalone software. It can work independent of the relay manufacturer. I don't care about the bias equation. I don't care about the relay manufacturer or the type or the model of this protection relay, but I care mostly about the behavior of that protection relay. Is it applicable to protect my system or not? Let's start with a practical example. I will start with software before using this to inject signals into the protection relay and getting the feedback. Let's close this presentation and stop. Start the relay test. Relay test. The latest version is 3.4. Let's start from scratch, one example from scratch. New test document. We will find here 4 choices. Choice number 1 is about the template, something similar to the BTL, ready-made, only just you need to adapt the power system data as per your application. We can also use one from the personal template. If you created your own template, you can start from a line topology, you can start from the substation topology as well. Let's start from the template. Here we have different application. I will start now the transformer protection. We have different here, including the tab changer, which is something amazing here. You can do a complete this with different tab position. Also, we have here phase shifting, which is a special application in some networks. We have here 3 winding and 2 winding. Let's start with the 3 winding. This is the same application which we have it right now. Here we have 4 sections. Section number 1 related to the reporting. This, and also you can add the logo for your company here for the better test report. Here this is data which you would like to have it on the test report. This data is related to the testing engineer and the title and all of that. This is only related to the report. Then the most important part, which is a system under test. This is a very important. This is the topology of your system. Here we have a topology. Instead of the parameter setting of the protection relay, we need to add the power system data. Like here I selected already the power transformer, and the power transformer you need to feed the primary, the secondary, and the tertiary, and don't forget the power as well. Those data should be available, and mostly those data from the power system data, not from the protection relay. This is the benefit behind using this approach, that it's not related to the relay manufacturer power system data, or I'm sorry, not related to the relay power setting, and it's not related to the model or the manufacturer of the relay. I don't care here about the bias equation. I don't care about the internal setting. I care about the power system topologies, the main data of the power system should be applied here. One of the most important thing, or the something that's amazing, in case you would like to test the restricted scope, just here. Here we have the star ground. The star point is grounded. I can easily add the neutral CT by only just click here, and I can also double click the CT to change the topology, as you see, to change the polarity toward this object or toward this line, very easy by double click. And also I can give the CT ratio, and also in case you would like to do the simulation for the saturation, one of the very important thing here, you can edit the CT data. You can edit manually from the nameplate, or if you have a CT analyzer test report, you can easily import it. Just I can select. I think I have, okay, I have a report. I can share it with you here as an example to show you that with the CT test report, you can easily use it to import all the data related to here. This is the test report. I can easily double click and automatically it's imported all the data related to excitation curve, operating burden, and also primary rated current available here. Everything is already become automatically, which now makes our CT is very, very realistic to be simulated. Coming back to the bar transformer here, if you would like to do a kind of transformer with a saturation, this is also can be easily adapted by entering those data. Those data you can get it from the power transformer manufacturer. This is some of the information here. It is a part of the FAT test for this power transformer. If you would like to apply it, I would like always to apply this to make it more realistic, but the information is very important to be added. Coming here to the third part, which is related to the hardware configuration. As we agreed, here we have a tertiary. It means one CMC is not enough. You need two CMC at least. One CMC for 6 current, another CMC for the other 3 current. You can come here, you will find two CMCs. Double click on this, you will find that, okay, the first CMC will be connected to 6 current, and for sure to receive the binary input of the tripping. You can change all of that, free to change. And now coming back to the second CMC, CMC is connected to the three-phase current only for representing the tertiary. No need for the input or output because feedback coming connected to the CMC number 1. This is all to check. Only so just choose here, and from the list we'll do that practically once I will turn it on, and you can see here how it's look like. The fourth section, which is related to the test cases, test scenarios, test points. Very easily we have here different test cases. Some represented the stability, which is a normal load flow. It can also use the external fault from the primary side, secondary side, or tertiary side. How to do it? Very easy. This is a normal. In case you would like to add a fault, see here it's a very, very easy and graphical method. And once you allocate a fault, it's automatically will be recalculate and it change the output signal very easily. Also here you can change the fault phases, line to line, for example, or three phase, for example, to ground, three phase only. You can find it, it's very, very realistic and a very strong, powerful tool to real simulate a signal, which is a relay will see it during the fault, real fault condition with a transient simulation. This is a very important, and also you can change the fault inception angle. You can control when exactly the fault will occur. Not only that, you can also very easily go to vary parameter and select which parameter you would like to add. For example, this fault I would like to change different scenarios with different inception angle. Here, add different values. And also you can change something else, maybe fault type. Here you are able, maybe I'm using the randomly. Only just click add, see here what will happen. Wow, a lot of test scenarios, very realistic, and each one of these of those is already calculated, ready now to be injected into the protection relay and getting the feedback. How to get the feedback? You can define the measurement from when to when, exactly like assessment of state sequencer, as you remember state sequencer. Then you can also add a different test assessment as per the expectation from the injected point. For sure, if I'm injecting stable or external fault, in this case it will start but no trip at all. If trip, it will give you fail. Let's take another example very fast about the a fault in zone. For example, in the primary, here I can allocate a fault in the zone. For sure, this can be internal fault and can trip the protection relay. And honestly, I can also add another fault inside the power transformer in turn to turn or turn to ground. Let's do it. Maybe I can show you one from scratch to add a new scenario to show you how it is easy. Here, once I select a scenario, I have two choices: simulate test or instruction command. Simulate test, which is the test scenario. This is like a boost module. I will select this one, and after that one, I will right click here and I will add a fault. Here, this is the fault inside the power transformer. You can select, you need it in primary, secondary, tertiary, different fault loops, and all of these. For example, for the primary, which phase is, again, you can also here coming back to vary, select the fault, and you can select, okay, for example, phases, inception angle, fault location, and give different selection to make a lot of test scenarios to meet your expectation from your protection system. This cannot be done easily by using the conventional concept or the conventional aspect or approach, but here it's very, very more easy, more graphical, and the simulated signal or the calculated signal more realistic to the real one. I already prepared one testing file for you. Maybe I will open the camera right now to show you what I did here with my system. I hope you can see. Now I have two CMCs actually. One CMC is 430, I may turn it on. Another CMC is CMC 356. The good behind using relay sim test, it doesn't matter the CMC type. If it has a license, it will communicate with the relay sim test. Then 430, 353, 356, 256 plus, all can be controlled by relay sim test. I use 430 for the additional 3 current to test the tertiary side, and I use the CMC 356 to use to connect to primary and secondary side. I got the feedback into CMC 356 with only one general trip instead of using primary, tertiary, and secondary trip. This is all about the power system. Let's now, I will disable the camera. I will disable the camera to make it clear for you. And I will open now an example which I already did it in advance to save your time. As you see here, I created a lot of the test scenarios. For example, here, internal fault when the primary and in secondary. I will do this with you now to show you practical example. Here, as you see here, if in case we have more than one CMC, it should be synchronized. Luckily, with the net 2 option, if you have a net 2 option, one CMC will be a master clock to the other CMC, and both synchronized together. As you see here, this will be 6 current, and this will be 3 current only, and this receive trip from the primary side. Just click clear all. I will clear all test results. I'm now able to start the test. I forget something very important, which is a wiring check, but because I did this before, maybe I bypass it, but later on I will show it to you. Here, as you see here, internal faults in primary winding with different location, turn to ground. Also, something good I preferred a lot, especially if you have many signal to be connected here, that you will have here the digital input. Just 1 minute. Okay, good. I have 1 point is failed, and this is with a reason. I will tell you why. This is very close to the star point grounded, and 1%, if you remember, restricted fault should be trip, but here, because we disabled the restricted fault, differential didn't detect it, and this is the main value of relay sim test, to discover the problem, not of the relay. It's not a problem of the relay, because another function can detect which is a restricted fault. If I enable restricted fault, this fault should be detected. Let me show you how to make sure that this point will be okay. I clear the result. Instead of 1%, I will make it 10%. Very critical value. Let's see how it will act now. Okay, now it is detected by the protection of the differential because it's 10%. But if it is less, then the restricted air fault should taking care about that. This is one of the feature which is very important to be considered during the commissioning and during the maintenance, to make sure that your system is ready. As I mentioned here before, here we have also the trip condition is available here. You have two cruiser or two cursors. You can also use it to determine the value. You can easily here get bin for the measurement, which will help you a lot. Here, for example, pre-fault condition, here fault condition. This tool can add a lot of measured and calculated value. It will help you a lot. Coming back to the point, which is checking the measurement, only just here check wiring. You can find easily here the signal. Just start, and you can get, okay, I got the trip here because this is a differential trip, and I have to read out those value from the relay itself. This is for the primary and secondary. I have to do the same for the tertiary as well. No trip because it's not connected, and I have to read those values from the relay itself to make the wiring check. For sure here I did only this point, but I can start all together, but only to show you that this is how to deal with relay sim test, how it is easy, how it is very effective and very high value to be added with conventional testing as well. This is all for our webinar for today. I will be very happy to receive all your questions, and if we have time, I will try to answer it now. If not, please share your question with me by email or send it in the chat, and I will consider that to be replied later on by email. Thank you very much. Thank you for your time, and thank you for Ali. Microphone is yours now. Ali, can you hear me? Didn't uh, uh, we didn't get it on time. I will try to communicate with you through email. The same question which I got it before, which is related to the zero sequence elimination, and what is the problem if we got the zero sequence in the zone of the protection. Differential protection, especially if you have a winding star grounded. If we have external fault line to ground, this will circulate a current in the protected zone, and it can lead to misoperation by the protection relay. And you need to do a zero sequence elimination to avoid such kind of misoperation. I have another question from Mr. Mongali. Can we test all the three winding at the same time? That is primary, secondary, and tertiary. I think, Mr. Mungali, we already answered your question during our session about relation test, and I showed that by a practical example that I have three winding transformer, primary, secondary, and tertiary, can be tested by relation test by using two CMCs at the same time instantaneously. And this is one of the good applications that you can use multiple CMCs with only one software as a relation test to control all of them together. I hope that this my answer is clear for you. Why REF 615 is a voltage actuated through relay through its REF protection between practice differential protection. How is it tested? Mr. Summit, maybe I can share my screen with you, Mr. Summit. First of all, REF, as I know, it is feeder protection. What does it mean by feeder protection? It's not related to a differential, but maybe you mean RET 615, which is the transformer differential from ABV medium voltage. I will share my screen to show you such kind of application, how to do it. I hope that you can see my screen right now. Here we have advanced differential test modules. I will open a differential operating characteristic in case you would like to apply voltage during testing the differential. It is a helpful tool to be used in generator protection, and in case you have voltage restraint also in such application, you can use here from the general tab. There is a voltage output. Only just click this and you will find that voltage output can be applied primary or secondary side to overcome the problem of that kind of setting. I hope this is clear for you. Maybe I need to continue again with other questions. Sorry to take more time. Mr. Mohsen, great session. Keep it up. Thank you very much, Mr. Mohsen. It's an honor for us to have you in this webinar, and all of you for sure for attending this webinar. Auto transformer can be classified as 2 or 3 winding with respect to the differential protection. Mr. Onomuko Okoko, I think Mr. Okoko from Nigeria. Yes, Mr. Okoko, auto transformer can be used as a 2 winding, 3 winding. Always, from my point of view, a voltage transformer for me, voltage divider. You have the same coil. It's different than a multi-winding different coils. It's the same coil, and you can have a tabs, and based on the number of the tabs and the position of that tab, you can find how much is the voltage output. Then the whole winding will be as a primary, then the second tab will be for secondary, and in some cases you can also take tertiary as well. Do we have a recording of this seminar? Yes, for sure we will send this by email. And please keep in mind, I have a very, very useful application notes, how to test restricted threshold with 3 different methods. my colleague Marwa will share it with you by email. And don't forget that also it can be tested by relation testing. Do we have again, the other question is can we have the presentation through email? Presentation is already available and exists in the section of hands out. Please try to download it right now. It is already still available until the webinar will be ended. Mr. Sabine Qadir, what is the recommended setting for fifth harmonic? Mostly from my experience in the field, I always find it from 38% up to 45%. But honestly, the fifth harmonic setting, it should be calculated with respect of the transformer design because it is different from one transformer to another transformer. But this is the common setting, but we have to take care about the design of the transformer. The other question from Mr. Mubashir, I hope that I can read the name correctly. Is this presentation over? Yes, the presentation is over, and only now we are answering the question. Another question is relay sim test almost same as RTDS real-time digital simulator, Mr. Mark? Thank you very much for your question, Mr. Mark. It's not exactly the same, maybe the same concept. There is a big gap between RTDS and our solution. Our solution is a site solution. RTDS is a lab solution, and RTDS is a very strong processing for complete network for a country, for example. But relation test can do much better at site in case you would like to test end-to-end or even a bus bar protection inside the substation or even mini feeders, but for sure not the same as RTDS. RTDS, it is a lab for R&D, for research and development on your network. You can study your whole network together. Relation test can help you at site for testing for sure. Another question from Mr. Gauda. He said that is relation test software is paid, license, or free? A good question. I already mentioned in our webinar that it is free of charge. You can download it from the customer portal to have it as offline. Once you need to connect it to the CMC to inject, at that moment you need a license. But please, my advice always before asking for a license, go to the customer portal, download it, use it offline. A lot of benefits there. Do a hands-on and a lot of practice, and you will find it a very valuable software. At that moment, you can ask for a license. Even if you would like to try it for some time, no problem. Just contact us. We will provide a timed license for your trial. Another question from Mr. Samir. I have a notice that difference in entering NVA for parameter-based testing and relation test. Yeah, it is. You have to enter the power of each winding. If you have a different winding, if you have different more than 2 winding, if you have 3, for sure we have to enter each one separately. If we have only 2 winding, it's useless to put different power because it should be the same B in equal to B out. Maybe a lot of question actually. Thank you very much for all of that question. I will try to select some, and the other I will try to reply by email. Maybe we can take Mr. John, he asked about what are the other 2 restricted S-fault to low impedance method aside from single phase differential. Thank you very much again, Mr. John. You will receive an email with 2 other techniques. One with the advanced differential operating characteristic test module, which is a 3-phase. We are adapted it and work around to make it adapted to test restricted S-fault. The other application, same to test restricted S-fault, but at this way, we are using state sequencer, a general test module, instead of a dedicated test module. And for sure, as you already mentioned, single phase differential can be used as already we discussed in our webinar. Mr. Gauda, thank you. You are welcome. Thank you, sir. Really, we have a lot of questions, but I know that the time is over now. Excuse me, and please forgive me to end this webinar for today. Very happy to be with you, and I will try to answer all of your questions by email. Thank you very much. Looking forward to see you again in our webinars. Thank you very much. Goodbye. Salam.